So if we look at the gradient flow, so in the forward pass, we'll start with 3D Gaussians, and in the rendering, in the forward pass from 3D Gaussians, we'll splat it on the screen, on the scene, and we will get a rendered image. So that's the forward pass. Now using that rendered image, you will calculate the loss. We'll compare it with the real image, calculate the loss, compute the loss, and we will tweak the Gaussian parameters. We'll tweak the parameters for like all the 1 million Gaussians. We'll tweak the Gaussian parameters in the reverse direction. So in the backward pass, what we'll do is that we'll calculate the image error loss. Based on the loss, we'll start tweaking. We'll tweak the parameters and we'll go in the reverse direction, like from blending, rasterization, projection, like that. So once again, I'll tell you what is happening. We started with 3D Gaussian in the real world. We splatted it on the scene to get a rendered image. Now we'll compare that rendered image with the original image, we'll get the loss. Now once we get the loss, we'll go in the backward direction. Like we'll go to the blending stage and we'll try to minimize the loss. We'll calculate the gradient, we'll tweak the parameters. Like we'll try to we'll calculate the rate of change of L with respect to Gaussian parameters. For that blending phase, whatever the formula is, we'll optimize that. Then we'll optimize the rasterization. Then the projection will optimize. Like that in the backward phase, we'll keep on doing it. Then once again, we'll do the forward pass. We'll get an image. Now the image we'll get, it will be more closer to the reality. And like that, we will do it thousands and tens of thousands of times. And finally, the rendered image will start looking very similar to the real image. The goal is to minimize the loss. And hence, differentiability is very important.